what we are starting today is Chapter 5. We are starting Chapter 5 today. Now, one thing I will say with this here, because we are starting Chapter 5, we obviously won't finish Chapter 5 before spring break. Because we only, not counting today, we have 5 days, because next week's only a 4-day week. So we will get partway into it. We'll finish 5.1 and 5.2 in those 5 days, and that's going to be about it. We will go back over it, 5.1 and 5.2, kind of a refresher when we get back from spring break. But one of the biggest things I would emphasize, again, is doing these assignments before spring break, or if you get the notion to do them during spring break, that would be helpful. Because I will say this, the tests, some of the tests and some of the hours were fishy. The fact that you got the answers for the equations without solving anything, especially since some of them came out as fractional answers. And we have not emphasized how to do or get fractional answers on the calculator. A little fishy. So, and again, I think some of y'all felt that the test was challenging or difficult. And if you have been using other methods to find the answers and get the answers for the homework so you don't have to do as much work, is nice on the beginning, but kind of kills you on the back end, because by the time you get to the test, that's going to be the first time you've actually had to solve or work any of the problems. Doesn't help. And again, at the beginning of any of these lessons, I do ask for homework questions. That is not something that's mandated by the state or the school. I'm doing these to guys to help you. If you get stuck on a problem, so you're not spending multiple hours to actually figure it out. So asking is one of the biggest things that can help you. And again, we do the makeup points. All you got to do is come in and correct the ones you got wrong, and you'll get half the points back. Mathematically, as long as you get above a 20%, you can actually do the makeup points and get passing. Because if you get a 20%, you lost 80% of the points. Half of that is 40. So we'll take it from a 20 to a 60%. And again, I can help you with the makeup points to get the right answer. Now, all that being said, what we're starting today is Chapter 5, which is going to be dealing with radicals, our square roots, nth roots. And the first thing we're looking at is the square root of 64 and the cubed root of 64. I've seen some of you have already been trying to work on it to figure this out. Which one do we think is greater? The square root. Because what is the square root of 64? Hey, because we're looking for a number that multiplied by itself will get us to 64. The cubed root is we're looking for a number not times itself, but multiplied by itself not twice, but 3 times. And the cubed root of 64 is 4. And 8 is bigger than 4. Because the bigger the root, that means the more times that number has to be multiplied by itself. And realistically, this first part of the lessons is going to make radicals, especially taking the square root of x squared or the cubed root of x cubed, make a lot more sense. Because we can actually change a radical into a fractional exponent. The nth root of a is equal to a to the 1 over n. The nth root of a is equal to a to the 1 over n, as long as n is greater than 1. Realistically, what we can say is that the nth root of a to the x, a to the x over n. The root is always in the denominator of the fraction, and the exponent inside or outside goes into the numerator. So the square root of x squared. Well, it's understood that the number inside the root, our index, as it's called here, is 2. When it goes on top, index on bottom. Well, what is 2 divided by 2? It's just 1. So we have x to the first, which is x. This rational exponent, the fact that we can rewrite a radical as a rational exponent, is exactly why squares and square roots cancel out. Cubes and cube roots cancel out, is because of the fact we're really just dividing by the root. And that's really what we'll be looking at for today and tomorrow, is how these roots and our rational exponents really work together. We're looking at this here, A, B, C, D. It might be looking like there's not a whole lot to do here. This year, we're really just reiterating that these are the same. That the square root of 9 and 9 to the 1/2 are the exact same. So the square root of 9 we know is what? So we can plug in the calculator, square root of 9, hit enter, and it tells us that it's, surprise, surprise, 3. Now if we look at the other side, 9, we can use our caret key to get the exponent. And the other side of the equation said 9 to the 1/2. So we can say alpha y equals, enter, 1 over 2. And 9 to the 1/2 is still 3. Well, we know the square root of 9 is 3. Well, 9 to the 1/2 is still 3. We're still doing the same operation. It's just written in a different way. Now, we don't have to do the alpha y equals, because 1/2 is the same as what? 1 divided by 2. 1 divided by 2. What's 1/2 as a decimal? So what do we expect 9 to the 0.5 be? There's different ways to write 1/2. And they all work. Really, why we're doing this is because we know that this is 3. And we saw just multiple times that 9 to the 1/2 is still 3. These fractional exponents will give us the same answer, the same value. A lot of times it's easier to type in. If we looked at the square root of 2 and 1/2, 2 to the 1/2, well, we can go second square root 2 and hit enter, and we get 1.41421, and it goes on and on. We can also look at 2 to the 1/2. 2 to the 1 divided by 2. And we get the exact same value. So these fractional exponents are nice to work with. Okay. Now the last one they gave us was the cubed root of 8 and 8 to the 1/3. In the calculator here, the cubed root, we have to go math and scroll down. Now the fourth one down is the cubed root, and the one after that is the nth root. The nth root is just any root, so 4, 5, 6, 7, 8. So if we do something bigger than 3, we would actually use this one here. Even if we wanted to use it for 3, we can. Because when I use the x root, is it wants me to type in the root that I want. So 3. So we can type in the 3, cursor over, and the number we want is 8. And the cubed root of 8 is 2. Now, if we want to look at the fractional exponent version, because we could do the alpha y equals and type in 1/3. We can say 1 divided by 3 and get 2. And we see that we get the exact same thing. Could I use the decimal version of 1/3? Because what's 1/3 as a decimal? It's like 0.33333333. It's 3 repeated. We can't actually write 3 enough times to get there. So thirds, it's not as convenient to write it as a decimal, because we could get there eventually. I put it that many times, let's see what we get. Okay, it's not getting us to the exact number because I didn't include enough 3's. So we could do it eventually. The calculator will realize we're talking about 1/3 and we'll round it up to 2. But that's more tedious than it's worth. I would stick with the division if we're having to do it that way. But we do see that both of these work out to be 2. So this fractional exponent and the radical work out to be the exact same. And that's really what this is trying to emphasize. Any questions on this here? We want to evaluate each expression. All right, so the first one we're looking at is the square root of 5 to the 3rd. Okay. One way we can do this is just type it in. We can say parentheses, second square root of 5, close parentheses. So we have the square root of 5 in parentheses, and then it's to the 3rd. Enter. Well, it gives us 11.18033,989. And what that tells me is I can't take the square root of 5, because there's not a number that multiplied by itself evenly that actually gives us 5. We'll go 2 decimal places. So this here is really equal to 11 point, I think it was 18. Yep. Questions on this here so far? Now, if we wanted to, the square root of 5 can be rewritten as 5 to what fractional exponent? Because the number in our radical is 2, so the denominator would be 2, because the index of what root we're taking is always in the denominator of the fraction. So since we're talking about a square root, the index is 2. The number inside here is 2. And the numerator is always going to be the exponent attached to the number inside. If there's no exponent, it's understood to be 1. So really we're saying that this is 5 to the 1/2 to the 3rd. Any questions on this here? Well, powers of powers multiply. So 1/2 times 3 is 3/2. So we have 5 to the 3/2. Come back over here and say 5 to the 3 divided by 2. We get the exact same thing. Because 5 to the 3/2 is the same as the square root of 5 cubed. Any questions on this here? Mm-hmm. Now we can look at the next one, the 4th root of 4 squared. Yes.
4 through the 4 squared is
actually 2.
because we could plug that into the calculator and it would tell us that it is 2.
Now, if we rewrote this as a fractional exponent, the exponent attached to the 4 inside the radical is, well, 1. Now, the root this time is 4. Our root, our index, is the number inside that little v. This one here we won't, but if it asks for it to be in radical form, we're going to need to. This here, we would, if we wanted to leave it in radical form, we can't say 11.18. Because this here, 3 halves is the numerator is bigger, yes? Numerator is the top of the fraction. 3 is greater than 2. So this is an improper fraction. So this here, really, if we left it in radical form, is going to end up being 5 times the square root of 5. Because 5 squared root of 5 is the 11.18. Because if it's left in radical form, it's telling us we can't approximate, we can't have it as a decimal. We have to have it in this form here. We have to have the radicals. So anytime it doesn't come out to be a whole number, we've got to break it down. Now, we'll deal more in that and how that works in 5.2. This here actually does work out to give us 2, and it's actually not that bad. Because if we rewrite 4 through to 4 as a fractional exponent, we get 4 to the 1/4 to the second. Well, powers of powers multiply. So we'll have 2 times 1/4, which is 2/4. Well, 2/4 does reduce, yes?
2/4 reduces to
1/2.
Well, 4 to the 1/2 might be a little hard for us to think about, but 1/2 is the same as, in radical form, the 2 would go back into our index, which is just telling us we have a square root of 4, which is 2. Is the 2 in the bottom would become the index, and the 1 is our exponent. 4 to the 1 is just 4, and that tells us that we're taking the square root of 4, which is just 2. Questions on this here? The cubed root of 9 squared. Well, if we wanted to rewrite this, kind of using that fractional exponent, just so we utilize this and get familiar with how this works, the 9, the cubed root of 9, as a fractional exponent. Now, the numerator of the fraction would be whatever the exponent is inside the radical. Well, there's not an exponent inside the radical. We just have the 9. So we can say that it is to the first. And the index, the number inside the root, is our 3. And again, we're utilizing that the nth root of a to the x is equal to a to the x over n. Well, powers of powers multiply together, so telling us that we have 9 to the 2/3.
The first one, yes, but this one here, not so much, because at this point here, we're looking for a number that multiplied by itself 3 times would give us 9, because that's where the cubed root would be. Well, the square root of 9 would be 3. So we're trying to see if we can take the cubed root, and unfortunately here we won't, we can't. So we'd have to approximate. And we can use the calculator to approximate 9 to the 2/3, which we could say is 4.33 if we're going to 2 decimal places. Thank you. And that's it. Any questions on this here? Now for this one here, we could have, if they were just asking for the decimal approximation or evaluate each answer and round to the second decimal place, we can just plug it in. So like D, well, inside those parentheses, we're taking the 5th root of 10. So if we're trying to find the 5th root of 10, we're trying to find out what number times itself 5 times is 10. Do we think that there's going to be a 5th root of 10? No. So we could come over to the calculator, because again, here we're just wanting to approximate, and go parentheses, math, down to the 5th one, and say 5, 5th root of 10. And it would give us an answer, but we don't just want the 5th root of 10, we also want it to the 4th power, yes? 4th, enter. We get 6.309 or 6.31. So, okay, 5th root of 10 to the 4th. Yeah, I had to reset the calculator. I think something got typed in or programmed in that was kind of making it act funky. Yeah, because the yellow calculators can do this also. Any questions on these here? All right. So we'll look at these two here, 8 to the 2/3 and 6 to the 5/2, because these here aren't really any different, because we could plug these in to get an answer. Because for 8 to the 2/3, we can take the calculator and go 8 to the 2 divided by 3 and hit enter. And this one, it works out to be 4. So here, 8 to the 2/3 is 4. We can do the same thing for 6 to the 5/2. 6 to the 5/2. And we get 88.18. Any questions on any of this here? Is it surprising that 8 to the 2/3 gave us 4? Or that 6 to the 5/2 gave us 88. Surprising that for the first one we did, it got smaller, but the second one it got bigger. So how are these different? Because that is part of it, and that's actually all of it, why they went smaller or bigger. What is 2/3? Well, 2/3 is less than what? 1. 5/2 is greater, yes? Because really we're saying that I'm multiplying 6 by itself. Well, 5/2 is the same as 2.5. I'm multiplying it by itself 2.5 times. The half is not going to be 3, because it would be whatever the square root of 6 is. 2/3, well, I'm saying that I'm multiplying 8 by itself 2/3 of a time. It's not even multiplied by itself a whole time, so we should expect it to get smaller for 2/3, and for 5/2 it should get bigger. And those next two are the exact same, because we can plug them in and we would get the answer, which really doesn't tell us anything. But let's look at these here. We want to evaluate 4 to the 3/2 without using a calculator. Now, one of the easiest ways to do this is if we can rewrite the number itself as a number to a power, it's going to make these a lot easier. So when we look at 4 to the 2/3, not 2/3, 3/2, what number times itself, a certain number of times, would give us 4? 2, because 2 to what power is 4? 2 squared, because 2 squared is 4. 2 times 2 is 4. And if we can rewrite these numbers, so 4 is 2 squared, or if we can rewrite 32 as a number to a power, it's going to make these a lot easier to work. And especially in this case here. Because again, powers of powers multiply. So we would do 2 times 2/3. The 2 would multiply with our 3. And 2 times 3 is 6. Now what is 6 divided by 2? I can do 2 to the 3rd. Because it's just multiplying 2 by itself 3 times. Because 2 squared would be 4. Multiplied by 2 one more time would tell me that 2 to the 3rd is 8. And that's it. So if we can rewrite the base, the 4, as a number to a power, so here it worked out 2 squared, we can then multiply and simplify. And it does work out nicely that here we could rewrite it as 2 squared. So for our next one here, what are we hoping that I can rewrite 32 as a number to what power? What power do we want? The power would be nice. Yeah, 5. Because here the 2, this 2 and this 2 really simplified each other out, didn't they? So here, if I could rewrite 32 as a number to the 5th power, that 5th power and that denominator of 5 would simplify each other out. Well, one way we can do this is a factor tree. What's the smallest number that'll go into 32? It would be 2 times 16. Well, 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 1, 2, 3, 4, 5. So really we can say 32 is 2 to the 5th.
Now again, just like before, we can multiply powers of powers. 5 times 4/5 would actually be 25ths, because the 5 and the 4 multiply together. Now 20 divided by 5 is going to give us back to our 4. Now we just need to figure out what 2 to the 4th is, which would be 16. Because 2 to the 3rd is 8. We just need to multiply by one more 2. And 8 times 2 is 16. Any questions on this here? Okay. We'll look at these next two here. So the next one we have is 625 to the 3/4. And again, if we're not using a calculator, it'd be nice if the exponent for this here is 4. Because if the exponent is 4, then the 4 and 4 would simplify. What is a number, a prime number that we know for sure goes into 625? 5. Because any number that ends in 0 or 5 is divisible by 5. So 5 divided by 625 is going to be 125. Well, we do have a 5 again, so 5 is divisible by 125, which would be 5 and 25, and 25 is 5 and so we do have 5 4 times. Now, as we've seen a few times now, this 4 and this 4 here are really going to do what? Cancel out. Because whenever we multiply with the 4, it multiplies with the numerator of the fraction, and they would end up canceling out. And 5 to the 3rd is 125. Now the last one we're going to look at of this type here is 49 to the 3/2. Now 49 to the 3/2, well, I can rewrite 49 as 7 squared, because 49 is one of our perfect squares, because 7 times 7 would give us 49. And again, when we multiply our powers of powers multiply. So our 2 times 3/2, when we multiply these, we would get what? Yeah, 6 over 2. And 6 divided by 2 is 3. So now we just need to figure out what 7 cubed is. 343. Because realistically, unless it tells us we can't use a calculator, we can just use a calculator on most of these. Because it helps you understand the principle behind what we're doing. Because if we don't understand what we're doing, when we actually take this beyond this, where we're not looking at just a number, it's not going to make any sense. Because again, we need to know the reason why behind what we're doing. Just this is what you do doesn't help you. Because if it's just something that we're thinking about, okay, this is what we do, this is what they said us to do, and we don't know why, it really defeats the whole purpose. And I mean, that isn't just math, that's anything.
because I know several of y'all play basketball. If we don't know why we need to go man-to-man or screen, we're just doing what coach said. You don't know what you're doing. You're just out there in a spot trying to do whatever coach said. If we know why, we can understand and actually apply it better. And that's why we're looking at this here. Because yes, we could plug 49 to the 3/2 in, but if we don't understand this process here, none of it makes sense. Especially up to this point now, y square root of x squared equals x didn't make a whole lot of sense. It's just, okay, they canceled out. But really, this is delving into the fact that we're saying that we actually have x to the 2/2, because the square root is saying that I actually have x to the 1/2, and it's being squared. So we really have x to the first, because 2 divided by 2 is 1. This is why this works. And is why this is actually kind of nice that this does work the way it does and simplifies the way it does. Now we do have one last thing, and this is the real nth roots that we work with. And the one that's really tricky that we have to pay attention to is if n is an even integer. Because if n is an even integer, it changes the number of roots that we can have. So if n's an even integer, so I'm going to keep doing that, a square root would be an even integer. Because we're talking about the index, the number inside the radical, or the number in the bottom of a fraction. If it's even and the number inside is negative, less than 0, we have no real roots. Because that would be taking the square root of -4. We've went over that because since it has a negative inside of an even root, it comes out as I. I is not a real number. So if it's even and the number inside is negative, we don't have any real roots. It's no real roots. Now if it's even and the number inside is 0, it's just 0. Because no matter how many times we multiply 0 by itself, we still get back to 0. And if it's an even root and the number is greater than 0, we have our plus and minus. We have to add it, plus and minus, whenever it's an even root. Odd roots, on the other hand, if the number inside is greater than 0, well, we have one real root. If the index is odd, so we're talking about, say, a cubed root, and it's 0, we have one real root, it's 0. And if it's positive, greater than 0, so the 5th root of 6, we're going to have one real root. So whenever that root is odd, we only have one root, only one root. And this is really only dealing with a single term. Because when we looked at the higher degree polynomials where we had the 5th root was the degree was 5, because we had other components besides just the one number, we would have more terms that could be real. But since we're just looking at the single number, we only have one. So find the nth root of a. So again, this we're just looking at the nth root of a. N, a. So for our first one here, the value of n is 3, and inside is -216. Now the index for this is 3. So the root here is odd, because 3 is odd. And since it's odd, we're either going to have one real root, or one real root, no matter what the number is inside. At this point here, we can type it in and get -6. Now I could type it in as the 3rd root of -216, or we could say parentheses -216, close parentheses, to the 1/3. Either way would work, but make sure if you do that, put the parentheses around it. Any questions on A? We ready to look at B?
Radical. The number inside our A is
81.
the index is 4.
Our number inside the radical, that index, is 4. So we're taking the 4th root of 81. Well, we can type this in a calculator,
And it would tell us that this is
3.
and we need the plus or minus.
Because here the root is even. 4 is even. In an even root, if the number inside is less than 0, we don't have any root. If the number itself is 0, we have 1. And if it's greater than 0, we have 2. We have the plus or minus. So that right there would be the answer. Questions on this here? And that's all we'd have to do for these here. Is really the rest of these, we're just typing them into the calculator. Any other questions on any of these here?
Oh, we can look at this one here before we officially wrap up, because this here would be the square root of
Negative 49.
So the index, the root for this is
2.
so it's even. So we have none, 1, or 2.
The number inside is
Negative, so this is no real roots. All right, guys. Your assignment is
245, 5 through 16. You don't have to do any of these by hand. You can actually use the calculator for all of them. Do pay attention to the index and the root so that you're making sure you're getting the plus and minus included or telling if it is no real roots. Also, all of your assignments for the last chapter are due by the end of the day Friday. Otherwise, they will be zeros.